Hello, welcome. This chapter is called Perception. Think of the word perceive. And now think of the word perception. They're basically the same word, just different versions of the same word. Right now you are looking at an optical illusion. And it looks like it's moving. I assure you it is not moving. If you don't believe me, touch. First of all, you should be looking at this on a computer for full effect, not with your phone. I'm going to be showing you a lot of optical illusions, a lot of weird stuff. But yeah, this thing is not moving at all. It just looks like it's moving. And if you touch it with your finger and you focus on any single spot, you'll see that it is not moving. It seems like it's moving because of the muscles behind your eyeballs. But this chapter is not really going to be about biology. It's a matter of how your mind interprets stuff. Okay? So here's another optical illusion. It kind of looks like it's moving, but it's not. So, all right, moving right along. So perception is how we perceive or interpret stuff. Like visual information. Usually we'll talk about visual information, but it can be other things as well. But the visual is the easiest to teach. Okay. All right, write this down. I don't know if I've ever seen bottom-up processing, but I've definitely seen top-down processing on the test. Top-down is when you focus on the big picture, then the details. It's easier to show you than it is to explain it. You focus on the forest, then the trees. However, bottom up is when you focus on the details, then the big picture. All right, moving right along, I'll show you a lot of pictures of what I mean by top-down processing. Here's something that's a little bit academic, but I think I can explain it good enough. Okay, so here is an example. Top-down processing is when you start with the big picture and you see two horses, a cowboy just trotting along up in the woods. And then you start to see the faces. And then you see even more faces. The longer you look at it, the more faces you see. And it's almost to the point where you don't even see the forest and the horses anymore, almost. This is an example of top down. Top down is when you start big, then you start to notice the details. Okay? Let me show you a bunch more examples. So, here is former President Bush. And that's what it looks like at first. But then if you start looking, you start noticing that this is a composite photograph of the men and women who died in the Iraq War. Okay, didn't mean to get all historical there. Okay, now let me give you a non-visual example. Read that. So it turns out that you could still read this, even though the letters are switched. Why? Because of top-down processing, you see the whole word, you see the big picture. You're not sitting there nitpicking how everything is spelled. I mean, you notice it, but you can overlook it. You look at the big picture, the whole word, not the details. That's top-down processing. Here's another example. So at first, you see a man, but then you pretty much immediately you start seeing all kinds of things. The windmill, the Spaniards. You see all kinds of faces. After a while, you almost don't even see the man anymore. That's top down. Everything on this painting is Snoop Dogg. Everything. All right, moving right along. All right, so what are we looking at? At first, you see a face, but then you see something interesting about the face. That's top-down processing. You have to know how to read cursive, L-I-A-R, liar. Moving right along. Okay, I think this is a good example of bottom-up processing. If you see the burger first, you see the fries, you see the ketchup, you notice that first, but then if you squint your eyes, you'll see somebody that I really don't care to see, but that would be an example of bottom-up processing. All right, moving right along. All right, do the question. The answer is top-down processing. So at first, you notice it's grandpa, but then you notice that the eyes and the mouth are blocked out. That's top-down processing. You notice the big picture, then you notice the details. All right. I don't love this question, but go ahead and give it a shot. The answer is top-down processing. Okay. Basically, Shaniqua sees the big picture, and then her brother sees something else. They both see the big picture given their own expectations, and they don't really get into it too much. I don't know if I'm explaining it well. Moving right along. All right. Read that. All right. The answer is top-down processing. All right. Moving right along. Okay, write this down. What is perceptual set? It's also been called perceptual expectancy. Okay, perceptual set. And I did just change the slide so you're not tripping. Perceptual set is when you expect something and that it affects how you perceive it. So we see or we perceive what we expect to see. It's based on top-down processing. So here's an example. The middle picture. What do you see in the middle? Well, it depends on what you are expecting to see. If you look at the left picture first, then the middle, you'll see a guy playing sax. However, if you look at the picture on the right and then shift your gaze to the middle picture, then boom, you'll see a woman's face. Okay. All right, moving right along. So I'm just going to show you some pictures, and I want you to put your phone down and look at these pictures. Okay, eyes on the screen. Okay, so what do you see? Well, if you've been paying attention, there's a decent chance that you would see an old man with glasses. However, if I were to show you these pictures, then you're starting to, in your mind, you're thinking mice and rats. So then I show you this same picture, you're more likely to perceive a rat because you see what you expect to see. That's what we mean by perceptual set. It's based on our experiences, our schemas, which that's a fancy word. Schema is a set of ideas that you have about something. Okay? All right. Here's a classic, I don't know if it's an illusion, but if you look at the middle figure, is that a B or is it a 13? Well, that depends on what you expect to see. It depends on the context. But I'll tell you what, though, you're not going to see A13C, and you're not going to see 12B14. It depends on the context is what you see in the middle. It depends on your perceptual set. And unfortunately, perceptual set affects human behavior because when it starts to get racism or stereotyping, representativeness, heuristic, when you get, you see what you expect to see with people. If cops chase an African American suspect down a dark alley, they are more likely, and they grab their wallet out of their pocket. The cops are more likely to perceive them as holding a gun than a cell phone or a wallet. Okay, that is a real thing in the study of criminology. Hey, you like fried chicken? What about that? You see, if you're thinking about fried chicken, you're more likely to perceive that as fried chicken. You like concerts? What about this? Ah, that's not a concert. That's a cotton field. Okay. All right, so do this. The answer is perceptual set. Kara is expecting to hear from her mother. So that's what she perceived it. All right, read this, do this question. The answer is perceptual set. It's about expectations. It's about schemas. It's about culture. All right, here we go. The answer is, all right. I know I'm beating this into the ground, but these are some interesting questions. Okay. All right, moving right along. All right, what did you see? Well, you might have thought you saw a bird in the bush, but in reality, it's a bird in the bush. Your mind is on autopilot. Top-down processing allowed you to see that as a bird in the bush, but it really says a bird in the bush. Okay, write this down and draw these on your notes. So Gestalt is not a dead German guy. It's not capitalized, but Gestalt simply means organized whole. It means that the whole is greater than the sum of its parts. So I'll give you an example. The whole, you might perceive an X, but in reality, there is no X because of the principle of continuity. You may see a circle, but there is no circle because of closure. Closure is when you fill in the gaps with your mind. You may see railroad tracks here, but in fact, you perceive that these two lines are related somehow, but we don't know if they're related or not. And you may see similarity. You may see rows instead of columns because of the concept of similarity. This is all in your head. It's not based in reality. You may see these two lines as related when there's no reason to think they are, other than the fact that they are close together. Proximity, near each other. Similarity, you may see three columns. You may not see rows. Continuity, you may perceive that as one continuous line. You may see that as one continuous line, even though they may not necessarily be continuous. Similarity, you may see a triangle when there is no triangle. Oh, I'm sorry, closure. Closure, your mind fills in the gaps. Okay? Take a look at that. Okay, moving right along. Same stuff, really. Proximity is interesting because as a teacher, when I see two students sitting next to each other, I always assume that they're best friends, and I assume all kinds of things. How many times in the lunchroom has somebody ever got onto you because the guy next to you left his tray or left litter laying around? And like, dude, I just sat next to the guy. I don't know this person. Similarity. When people wear the same color shirts, you think they know each other. How many times has somebody said, oh, you go to that school? Do you know Charles? Or do you know somebody else at that school? Just because you go to the same school doesn't mean you know the same person. I've never seen simplicity on the test. Don't worry about it. Okay. All right, moving right along. This is a classic illusion. Which gestalt principle explains why this illusion is what it is? Because of continuity and closure. We think of the red line as continuous. When the black bar is on there, we think of it. We do think of it as continuous when it's not. Closure, our mind fills in the gaps. Continuity, we perceive that to be an entire baby. There are no triangles. There are no stars. It's all in our head. Because of closure, our mind is filling in the gaps. Same thing, closure. There's no circle. There's no triangle. Similarity, we see rows, and over here we see columns because of similarity. Proximity. If two things are close together, we think they are related somehow. So we see columns, we see rows. And closure, our mind fills in the gaps. All right, do this question. The fact that objects that are near each other tend to be grouped together is known as, the answer is D, proximity. Think, if you speak Spanish, think proximo, okay? All right, closure, nearness, similarity, and continuation are categories of what? And the answer is perceptual organization. All right. The answer is, so your mind is filling in the blanks, so it'd be closure. All right, here you go. Read that. The answer is, again, your mind is filling in the gaps. Okay, figure-ground relationship. I really don't have a good definition for you, but I would draw a vase at least on your notes for figure-ground. Figure-ground simply says this, and I don't have a good short definition for you, but basically, figure is in your mind what is up front and what you're paying attention to, and the ground is the background. So on a figure like what you're looking at here, you can switch it. You could put the black as the figure. If you put the black as the figure and the white as the ground, you'll see a vase. But if you put the white as the figure and the black as the ground, you'll see two faces looking at each other. So this is called a reversible figure, where you can reverse the figure and the ground. You could do that in your head. Notice the faces. Okay, moving right along. So this is just like the other one. You can put the black as the ground, or you can put the white as the ground. Okay, I just thought that was funny. The reason camouflage works is because it's hard to distinguish figure from ground. So if you're flying up really high looking for airplanes, it'll be harder if the airplane is green, if the airplane is flying over trees. That's how camouflage works. What do you see? Hit pause. All right, so after looking at it for a while, you may see the word lift, L-I-F-T. The reason it's hard at first is because you have the black as the figure and the white as the ground. But if you put the white as the figure and the black as the ground, then you'll see it very clearly. That's why it's hard to see. It's about figure-ground relationship. All right. I have not seen this word on the test, but I have seen the concept where when you're hearing something and you can choose in your mind what to pay attention to. Okay, but I'll tell you what the cocktail party effect is. It's like if you're at a party, you have the ability to listen to one conversation, especially if that conversation has your name in it, right? You hear your name, you're like, what? And you have the ability to tune everything else out. So in a way, it's like selective attention. It's similar. Okay, try this question. The answer is B, figure ground. All right, try this question. The answer is figure ground. You have the ability to put the violin as the figure and put the rest of the orchestra as the ground. You have the ability to focus on one instrument and ignore the others. Just like the cocktail party effect. You can listen to one conversation and put everything else in the background. All right, here we go. Gestalt principles are used to explain what? The answer is C, perceptual organization. Figure ground, closure, continuity. Okay. I'm going to show you this video.
The brain is constantly bombarded by far more information than it can handle. If we tried to process all of it, we'd be completely paralyzed. As a result, we have to attend to only a small part of what's in front of us at any given moment. Sometimes attention can fail and we lose focus. This is what happens in what we call inattentional blindness.
Pay attention. You're about to be tested. For this game, you get to be the referee and judge whether the kicker is able to put the football between those two yellow uprights, 20 yards away. Tracking a small moving object at a distance might be difficult, so watch the ball closely.
Spirit, let's hear it. Spirit, let's hear it. S-P-I-R-I-T, Spirit.
So, was the field goal good or not? As the replay shows, it's good. Pretty easy, right? But while you were watching the kick, did you happen to notice which cheerleaders took off their tops? If you're looking for the rewind button, don't worry. We'll do it for you. Yep, there they are. While you were zeroed in on the kick, you missed 3 cheerleaders stripping down at the bottom of the screen. Don't be surprised if you missed it. We took advantage of a loophole in your brain. If you could rewind real life, you'd be shocked at how often inattentional blindness causes you to miss things happening right in front of your eyes.
All right, that's enough. So it's just like the moonwalking bear, okay? Selective attention leads to intentional blindness. Intentional blindness is when you miss something because you're focusing on something else. Okay? So basically, inattentional blindness is failure. Yeah, it's failure to notice something you weren't looking for, just like the moonwalking bear. All right, moving right along. All right, try this question. The answer is intentional blindness. Okay, so I taught you earlier that it was selective attention, and I was right. But now I'm teaching you the word intentional blindness. Don't think about it too much. Okay, moving right along. All right, I'm going to show you some optical illusions. What is an optical illusion? It's when perception overrides sensation. Okay, so your eyes play tricks on you. All right, so I'm going to go fast. You can hit pause if you want to look at them longer. Believe it or not, this is not a video. Okay, that's what's interesting. I could hit pause and you could hit pause in your video and it would still look the same. It's your mind playing tricks on you. You see movement when there is no movement. How many feet? I forgot what that's called. Here's an interesting optical illusion. It kind of looks like a pyramid, like it's coming out at you, like you're looking down on a pyramid. But you know what's weird is that all of these lines are parallel and perpendicular. It's weird. And here's a video of that. If you get rid of those little squares, then boom, it fixes itself for some reason. All right, moving right along. All of those lines are perfectly straight, not squiggly. Okay, that is not moving. That is not moving. Neither is that. It's not moving. Okay. All right, so this is kind of a new topic. Okay, so one of the things that you need to know is about what are called depth cues. And if you're ever getting into art or like video game design, you need to understand depth cues. And there's a lot of them that you need to remember. First of all, I want you to know that some depth cues require two eyes. These are called binocular cues. Now, what does bi mean? It means two. Monocular cues need only one. Mono. What does mono mean? Mono means one. Think of the word monogamy or monotheistic religion. Okay, moving right along. Okay, so there are two binocular cues you need to know. You need to know this one, write this down. Convergence says that when you are trying to focus on something very close to your face, you will cross your eyes, and the discomfort of muscular tension that it takes to cross your eyes will tell you how close something is. So if a fly is buzzing around your face, is it a really large fly that's far away, or is it a normal sized fly that is close to your face? So how far you cross your eyes will tell you how far away something is. Write down the red. Retinal disparity. Retinal, think of the retina as in the back of the eye. Disparity means difference. In economics, we talk about economic disparity, like poor versus rich. I don't totally understand this one, but I know what it is. I just don't know why it's a depth cue. But I do know that your left eye sees something different than your right eye. And your brain does something with that and creates depth. Somehow creates depth with that knowledge. Okay, so basically your left and your right eye see something different. All right, moving right along. All right, that's it. All right, so go ahead and try to answer this question. All right, this is an interesting question, but the answer is C. Retinal disparity is with eyes. Your ears do something similar. Your left ear hears something different than your right ear. And based on that information, you know where the sound is coming from. All right, do this question. The answer is, yeah, it's C, yeah. When your eyes turn inward, like cross your eyes. Okay, all right. Now, what if you only had one eye? Then you couldn't do convergence. You couldn't do retinal disparity. Then you would have to do other stuff. All right, and I'm going to give you a bunch of monocular depth cues. Okay, write these down. I'll explain these in a little bit, but you have them written down. Okay, now write these down, and I'll explain these on separate slides. All right, so because of the GIF, I want to explain motion parallax. When you're moving, closer stuff moves faster. Like the green here appears to be closer than the stuff in the distance. Again, there is no distance because it's a two-dimensional GIF. But if you're on a train, stuff that's closer to you will appear to move faster. Okay? Linear perspective. In the distance, lines seem to converge. Converge means they come together. That's why these two yellow bars look to be different sizes, even though they are not. They are the same size, but this one seems to be further away and it appears to be bigger. But both yellow bars are the same size. But linear perspective says that lines converge in the distance, parallel lines, like railroad tracks. Relative size. If you know a man is about 5'11" or 6 feet tall, and they are far away, and they seem to be small on your eyeball or on your picture, then that is the depth cue. You know about how far away those guys are. I'm not explaining it very well, but I think you understand anyway. Okay, interposition. When something blocks the view of something else, we perceive that thing to be closer than the thing it's blocking. So on your notes, you have the word overlap. Interposition means one thing overlaps with something else. So we perceive this dog as being closer than the white bars in these words right here. Here's another example. Overlap, interposition means that since this jar is blocking the words, then we perceive it to be closer. Why does Why is it hard to determine which one of these buildings is closer? Because it's hard to do interposition on this picture. Linear perspective, the lines come together in the distance. Texture gradient means that the closer it is, the more texture you see in the picture. But if you go further away, you don't see as much detail, not as much texture. Also, relative height. If it's higher up on the picture, you perceive it to be further away, as you should. Motion parallax, closer stuff moves faster. Stuff that's further away seems to move slower. Interposition, this balloon is closer than that one. Okay. All right. What are we looking at here? The answer is C. The lines are coming together like railroad tracks. That's a monocular depth cube. All right, do this question. The answer is motion parallax. All right, read that. All right, since JoJo injured her eye, she has to rely on monocular depth cubes. Which one of these is a monocular depth cube? The answer is linear perspective. A and B are binocular. D is not a depth cube at all. And B should be retinal disparity anyway. Okay. Visual acuity just means like detail. It kind of means the same thing as texture gradient. Okay. All right, read that. The answer is texture gradient. If you see more details closer up, that's called texture gradient. Sorry, I didn't teach that good enough. I'm trying to wrap this up. All right, that's enough. Thank you.